Hey guys, today we're going to talk about the third and final test statistic for testing independence. It's called the percentage of success, and it's very familiar to what you've seen in Unit 2. So the first thing is we categorize our data into 4 different categories. Success, which is like a yes, or make, or win. Failure success, that's a no-yes. Success failure is a yes-no, and a failure is a no-no. So yes in this case represents a success, and no would represent a failure. So we can talk about getting A's versus getting not A's. We can talk about getting making a shot versus missing a shot. So what we're trying to do is we're trying to compare if someone has a higher proportion, if this proportion is higher than this proportion. Is someone more likely to get a success after they've had a success, or are they equally likely to get a success after a failure and a success after a success? So it sounds kind of weird, but all we're going to do is we're going to categorize our data and look at the percentages that come up. So first, just to remind you, a player's outcomes are independent if his ability to be successful is the same following a success and a failure. That goes with our null hypothesis. We test the hot hand to see if there's a greater ability to be successful after a success. So let's talk about Shaquille O'Neal. Did he have the hot hand? So what we're going to be looking is a two-way table, and with our two-way table, we're going to group our data together. Remember when we did home versus away for a lot of our examples in Chapter 2? We found the percentage of home and found the percentage of away. So now what we're doing is we're taking the percentage of where he had a success, and we're going to subtract the percentage where he had a failure success. So this first box where he made the first attempt, made the second attempt, that's like getting an A the first time, then getting an A the second time, that's a yes. When he made the first but missed the second, that would be a yes-no. And just notice that I drew an N there because a miss the second should be a no. If he missed the first time and then made the second time, that's a no-yes. And these are the two important categories that we want to actually look at because we want to see if it's more likely to have a success after a success. And then we have also a no-no, so failure. So all you do is you take your data that's listed and you break it up into groups of 2. So if you have a long streak of yes, no, yes, you have to take your pen and break it up into pairs. Okay, so this is already broken up into pairs for us, and we actually just have to go through and tally where these values will fall. So what I like to do is I like to make a note of what each box represents so I don't forget. So I have a yes, so that's 1, a yes, and I'm just going to keep going through until I finish all of them. Hopefully you won't see me make any mistakes as I'm going. It's really easy to kind of get confused with all these N's and Y's. So just be careful, take your time. No, yes. Okay, and you'll notice I'm just going along, completing all these values so that I'm categorizing my data and ultimately can find some kind of tally mark and amount. I'm about done. No, yes. Yes. No, yes. Almost done. No. And no, yes. If you ever have someone at the end, like just a random N or a random yes, we don't have to actually talk about them because they don't have a pair. So their outcome after is really inconclusive. So the total number of yeses we had was 9. No yeses we had was also 9. The total games we played, or the total mades then missed, was 4. The total missed and missed was 5. So this total would be 13, 14, 18, 9, and 27. To calculate our test statistic, we find, we do the yeses divided by the total made first, and we subtract the no yeses divided by the total missed first. So in this case, he made 9 and the first and second time out of 13 total made first, and he missed and then made 9 but out of 14 this time. And you calculate that percentage by taking 9 divided by 13. That's going to give me 69.2%. and I'm subtracting 9 divided by 14, which is 64.3. When you subtract those two values, you'll end up getting 4.9. So he performed 4.9% better after he made the first shot in this given scenario. Okay, so that is my test statistic. Okay, so calculated test statistic, we found 4.9%. The hypotheses that we're testing are no different than really any of the other ones. So we'll say Shaq's free throw attempts were independent. And again, independent means he had the same ability to get a success after a success or failure. And then we'll say for the next one, Shaq had the hot hand. And hot hand, this time, means a greater ability to get a success after a success. Hot hand. Okay. From there, we can calculate and interpret our p-values. So our test statistic, again, was 4.9%. Okay, 4.9% as a proportion is 0.049. So 0.049, I'm going to say is maybe over here. And I'm going to go through this and I'm going to calculate and I'm going to count every single dot. 1, 2, 3, 4. A lot of dots. $51. So there's 51 dots out of 100 total dots. So our p-value is 51%. Okay, for my interpreting, how do we always start interpreting? We assume the null hypothesis, so assuming Shaq's free throws were independent. There is a 51% chance of getting, and this is where it gets a little bit different between the three hypotheses, a percentage of success of 4.9 or more by random chance. Okay, making my conclusion, I followed my 3 steps. Is my p-value bigger or smaller than 5%? So in this case, p-value is bigger than 5% because it's 51%. If it's bigger than 5%, there's a lot of dots that were generated by random chance, so that means that random chance is a plausible explanation. And lastly, which hypothesis does that give you evidence for? So we failed to reject null. We have evidence that Shaq's free throws were independent. Okay, so be careful. You'll notice on your last quiz, I can't say proven. I cannot prove that Shaq's free throws were independent. I cannot prove that Shaq's free throws had the hot hand. Each one of your dot plots, each one of your test statistics could be different. Each dot plot could be different especially. All of these dots are generated by random chance. So in any given time, random chance could give me another series of dots that gave me a different p-value and ultimately a different conclusion. So we can never prove anything. So be careful saying prove in your conclusions.